Hello everyone, good evening and good morning. Organizers, please confirm. Am I clearly audible? Thank you. Okay, friends, I see some of you are raising your hands, but this is not the right time to ask questions. So please save your question. We will have a question answer session every 15-20 minutes, right? So we have decided to make this webinar sessions more live and interactive. So we have decided to have, two to three question answer session instead of one at the end of the session. Okay, so just you can drop your questions in the, so there is a facility in the tool to drop questions. If you have any, you can drop over there. Those questions are going to be answered by me later. If you would like to keep your questions for the question answer session, keep them with you. Okay, and we will have discuss them out later on. Okay, so today's session, and I understand why are you here and why are you attending this session. So first of all, before I jump to discussing the topic of today's webinar, I would like to welcome all of you to this webinar on behalf of Cognitia. Cognitia is a Collabora learning solution company. And okay, is there anything wrong with the PDs? Okay, no problems. I'll answer the questions you have been dropping in the question panel, later on. Okay. So Cognitia, let me first introduce my organization, and then I'll share my introduction, and then we'll have discussion on how to develop IoT products, and that obviously you would like to start from the selection of, components, right? So we'll have a discussion on most of those topics in today's session. So let me first introduce my organization, Cognitia. As I just said, it's a learning arm of Collabora, and Collabora has been in the IT staffing domain. It's a global organization. It's been in IT staffing domain for more than 3 decades, and it serves more than 400 clients. And now, Cognitia, being a training arm of Collabora, has been, serving uh, the professionals who have been working with these organizations, and uh, through offering them skill development training programs based on emerging technologies. We have trained thousands of professionals across the globe, and most of the training programs being offered by us are valued across the industry, and we have bagged many awards in the past. So, for example, for IoT training, we have been holding #1 position for the consecutively for the last 3 years, and the content being offered by us and curated by us in-house is one of the richest content in the world. So apart from IoT, we also offer training programs on big data, cloud, all the top of the line cloud platform like AWS, Azure. We offer specialized and well-crafted training programs on data analysis and machine learning and AI. And there are, in total, we offer more than 200 training programs, most to cater the need of the professionals coming from diversified disciplines, and you all know most of the professionals have been facing a challenge now, and it is difficult for them to keep up with the accelerated growth of the technology, right? So this is where Cognitia comes, with a bunch of well-crafted and well-devised training programs to help you upskill and reskill yourself to keep up with the pace of the growth of the technologies. My name is Shafi Patel, and I'm the speaker today. Okay, and I have more than 20 years of experience, and that comes from several areas. For example, embedded systems, electronic system design and manufacturing, IoT, medical electronics, networking, IT, and project management. I have trained as a trainer. I have trained more than 8,000 engineering graduates and more than 3,000 corporate professionals. So that is just a brief introduction, and post this session too, we'll keep connected, and we'll continue our interactions. So when it comes to interaction during session, so I have this two guidelines for you. One is you can use chat window to share your suggestions, comments, or if there are any open house questions. And you can use audio mode to talk to me. So I'll keep all of you muted, and if wherever you use the hand raise option, and it's available there in the training tool. So generally we use hand raise options for our regular training sessions. In webinar, obviously, I will be able to take your questions only during the question answer session. And you don't need to worry because we will have more than one question answer session in today's webinar. Okay, so coming to the outline of today's session, I'm going to share, the definition of this fascinating technology. I'm going to share, the vision of the inventor of this term. I'm going to share, information about the economic potential of IoT and its application areas. Okay. Uh, I'll walk you through this concept of data and converting data into wisdom or intelligence, and then making it available to applications, those advanced applications which can consume this intelligence or wisdom to make intelligent decisions. I'll also talk about the architecture of a standard IoT system or solution, because it's always a combination of more than one component, right? So we'll have discussions around this topic, the anatomy of IoT system, its various components. I will share some basic understanding of and selection criteria of components like MCUs or SoCs, communication technologies, and protocols, and we'll also have discussions around selection of IoT cloud platforms. And then we'll have a discussion on one of the use case from healthcare domain. So this is the outline of today's session. The session, the duration of session uh, will be more than 1 hour, including your question answer sessions. Okay. So let me start off with the definition of IoT or Internet of Things, and we all know this is the technology has which is highly promising, and which comes with a impact. The impact is being experienced not only by individuals but by businesses, by manufacturing organizations. The inventor of this term is Mr. Kevin Ashton, and he coined this term in 1999. So, and according to him, IoT is envisioned by Kevin Ashton. According to him, IoT is the evolution of computers or computer technology, and that tells everything about IoT. Because computers, we all know how computers have helped us and have been helping us in transforming our world, right? So computers have been there, and computers are going to be there. Computers not are not going anywhere. The only thing is the computers and computing, you know, are becoming more and more ubiquitous. You know, now we have new generation computing platforms. It means computing is everywhere. It's you will find a computer integrated or embedded in your wristwatch. You will find more than one computer embedded in your car. Similarly, you will find computers everywhere. So generally, when it comes to computers, we come across three types of computers. Conventional computers like laptops and desktops. Generally, we use this type of computers for data processing. Industrial computers or PLCs, programmable logic controllers. This type of computers are used in the manufacturing industries to control production systems and production processes. The third type computers are, you know, called single chip computers or microcontrollers. They come in the form of small ICs, chips, you know, and these computers, they come embedded in larger systems. So I just gave you examples of some of the systems which are termed as embedded systems, or smart wristwatch with a computer embedded in it is called embedded system. A car with more than 50 computers, single chip computers or microcontrollers embedded in it is called or is another example of embedded system. A mobile phone, just to keep it simple for you, a mobile phone is also an example of a sophisticated embedded system. Right, so we have computers, and these computers are everywhere. Either these computers are on your desks, or these computers are there on factory floors controlling production systems and processes, or these computers are embedded in other systems. And I just shared few examples with you. So what's new? And the new, as Kevin Ashton explained, the next step, to take computing to next level is empowerment of these computers. And by this empowerment, he means, making these computers intelligent, making these computers context aware, making these computers, mindful, or as aware as we humans are, you know, and this could be achieved, or you know, by embedding or by equipping these computers with sensors, computers, I would say the application part of computing, actuators, and communication capabilities. So sensors, we'll talk more about them. Actuators, yes, they enable computers to influence the physical environment by generating physical actions. The communication part enable these computers to interact with other computer-based systems in around them, and that helps these computers to offer a kind of experience to end users, which was almost unimaginable earlier. So Internet of Things is, it is defined, it is the empowerment of mundane objects, as you can read here on my slide, through extension of computing and communication. So we are in the process of extending, these capabilities, computing and communication, to more and more mundane objects. So any object, for object is small and as trivial as your shoe or your wristwatch or your shirt, you know, uh, has the possibilities to be converted into an IoT product. Okay, and how to do that? How to convert a electrical system or a mechanical system or electromechanical system or a simple mundane object like a water bottle. How to convert them into IoT products. This is what we are going to discuss today. Okay, so this is one of the most fascinating technology of today's era. This is highly promising technology. And let us look at the next slide, which will tell you more about this objects, and how many of them are being anticipated. So when we look at the number of objects which are going to be connected to internet, or which are already connected to internet, so number of objects connected to internet had already crossed number of people connected to internet long ago, somewhere in 2003. And currently we have more than 20 billion uh, objects already connected to internet. So it means more than 20 billion objects are already connected to internet, and these numbers are growing rapidly. Okay, so it has been anticipated that by 2020 we'll have more than 50 billion, smart objects, smart and connected objects. And these objects, you'll find them everywhere, in your home, across the city, as well as at other public places, and in our factories, where this technology is being termed as fourth industrial revolution. So industry is all types of industries. Not just one uh, type of manufacturing. I'm not just talking about one type of manufacturing industry. All the manufacturing industries have been striving hard to leverage this technology. And this technology, it comes with a promise to help them not only save time and cost, but to help them take advantage of other types of capabilities. For example, the type of analytics that enables this manufacturers and their systems to predict the future breakdown of their machineries. Right? So preventive or predictive maintenance is one of the area where IoT is being leveraged by manufacturing industry. So we'll this 50 billion projects, they come from all these verticals. They come from consumer world. They come from manufacturing world. They come from our personal lives. So these objects are going to be everywhere, and this is the kind of potential IoT holds. And along with this potential comes the economic potential. So we'll have more discussion on the economic potential of this technology. Let us first look at where are this or where are you going to find this projects. I already shared some insights with you on the previous slide. And here, as you can see, IoT is almost everywhere. Its pervasiveness is almost unimaginable, right? So I talked about the connected industry, where even the adoption strategy of IoT has been standardized. So we have two leading IoT or Industrial Internet of Things standards. One is from government of Germany and a group of manufacturers from there. This initiative is called Industry 4.0, and this is one of the guidelines for the industries to adopt IoT in the right manner. Okay. Similarly, we have uh, another guideline from a consortium of company, and this initiative is led by GE, and this consortium is called Industrial Internet Consortium. And there is a reference architecture and guideline from there, from them. This is called IIRA, Industrial Internet Reference Architecture. Right. So these are the two guidelines which have been helping manufacturing industries to adopt IoT uh, in a manner which will help them get maximum out of it. Okay. If you look at the connected car, this is one of the area where you would see, if you'd find lots of innovation, and connected car, and it has been anticipated by that by 2020 will have 90% cars, connected to internet. you know so again, this is one of the area where new business models are emerging and evolving. For example, there is a concept of offering cars, as a service. So we already have this type of businesses in place. For example, there's online cab services, Ola and Uber, and similarly, there are other manufacturers who are coming up with innovative, business models, wherein like products is going to be offered to a consumer as a service. So anyway, that is a, different topic, and that can be discussed in a different types of seminar. But anyway, here I'll stick to you know technical subtopics. Okay. So I just give you examples of these two areas where IoT is being adopted at large scale, and there are other areas like connected cities and connected health, and uh, you know there are so many, right? So the question is, okay, all these industries are going to adopt IoT, but how are these application domains going to contribute in the overall global economic value of IoT, right? So if you look at the overall global economic value of IoT, it stands in at around 11.1 trillion dollar, right? And it has been like some of the survey has have revealed that IoT is going to contribute, almost more than 40% in the global GDP in coming years, right? So this is the technology which is highly promising. Okay, and if you look at the sectors which are going to contribute in this overall economic value of IoT, you know, obviously smart factories or connected industry holds number one position, and then we have other areas, for example, smart cities, smart vehicles, smart home domain, and retail, human healthcare. All these are the areas which are going to contribute majorly in this overall global economic value of IoT. Okay, so this is just an overview of uh, this technology and its application domains, its economic potential. Okay, so if you guys have any questions or doubts from this area, I'm uh, ready to take it. So in case if you have any questions or doubts, please either use hand raise option, or drop your question in the question panel, and I'll read your question and answer it for you. Okay, got any questions? Okay, so we have an interesting question, and this is really a great question. It comes from Amir Nadeem, and his question is why we call IoT instead of WOT. Okay, so yes, Amir Nadeem, I know about this concept, WOT, or Web of Things. This is the term recently, introduced, and here this devices are, you know, the idea is to transform devices into information sources. So anyway, whether you call it IoT or WOT or IoE or whatever else, these terms are being used interchangeably. But if you look at look inside an IoT system, and this is something that I'm going to discuss next. When you look at IoT systems, you will find IoT system a convergence of all these ideas and concepts, right? So all these ideas and concepts are being incorporated in building up IoT systems. Okay, so IoT and WOT or IoE, all this term, they all point to same thing, in a network of intelligent systems. That's it. Okay. Okay, I'll take few more questions. So we have a questions. Okay, could you please guide me on MCU SOC? Is there any difference between them? Vishal Singh, my next slide will answer this question. Okay, and then we have question. What need did he had to invent the term? Joshi Nishant. He says, why did Kevin Ashton invented this term? So Nishant, he was inspired, by this capabilities of computer systems. So according to him, these computers, uh, in their conventional areas were not being utilized, or their capabilities or their potential were not being utilized, uh, or you can say that these computers were being underutilized, right? This is why he came with this idea that once you empower these computers, they would be in better position to contribute, in a better manner, to not only improve your lives, also help industry and businesses to not only gain operational efficiencies, but also improve their processes and gain other capabilities. Okay. Okay. So most of the question I find, here in the slide, which would which are going to be answered, in my slides. So what I'll do, I'll just leave it at this point of time, and we'll get back to the question panel later on, because most of the questions which are being answered, are going to be answered, in the session itself. Okay. So I'll come back to you later to take the next group of questions. Okay. Okay, I can see there are 4 to 5 participants who have raised their hands. So let me take question. Vivek, I just unmuted you and getting lots of noise from your side. Guys, if you find that, the environment you are in is noisy, please do not use audio mode to talk to me. Vinay Raut. Okay, I cannot hear anything from him. Suresh Babu. Suresh Babu.
Yeah, there is no questions as such.
Okay, fine, fine. Okay, guys. So the best part is the best thing is I'll take the question from you later on. Okay. So let me resume the session. So I was talking about this IoT and its economic value and its application areas. Now let us talk about the IoT system or IoT solution. And believe me, when it comes to creating or designing or developing an IoT solution, it's really a complex endeavor. Why? Because IoT is not just one technology. IoT is an ensemble of multiple technology domains. Okay, so if you look at an IoT ecosystem, it would be a combination of devices, and these devices, or there are multiple term we use for them. Sometimes we call them things, sometimes we call them smart objects, sometimes we call them embedded systems. So this devices or things or embedded system, they are equipped with sensors and actuators, and that enables them to acquire data from the real life environment and to act respectively. Okay. The second component of an IoT ecosystem is obviously a network. And a network enables this devices, connected devices, to talk to each other. It facilitates that communication, or it enables these devices to exchange data with each other. The edge infrastructure and edge infrastructure, it refers to that group of high-end computers, called gateways. And a gateway uh, plays multiple role in an IoT network. I'll talk about more about this afterwards. And edge infrastructure also includes on-premises infrastructure. So let's say for an organization may have an IT infrastructure on premise. For example, a retail store may have an IT solution, running on premise, right? So this this area, it has there is one of the challenge being faced by IoT designers and developers, especially when it comes to edge infrastructure, is IT and OT integration. Integration of information technology solutions with operational technology solutions. Okay, so I'll help you understand how to address that challenge later on. We The next component that you would come across when it comes to end-to-end IoT ecosystem is obviously cloud platforms. And a cloud platform, offers a bunch of services to endpoints or devices connected to it. For example, storage and processing or analysis of data. These are the two uh, services predominantly offered to endpoints connected to cloud platforms. And then the next component that you would find in an IoT ecosystem is obviously a group of high-end applications, uh, and they come with different types of analytical capabilities, from descriptive analytics to prescriptive analytics. And the other two types of analytics we talk about are uh, diagnostic and predictive. So predictive is one of the analytics which enables systems and people, using those systems to be agile and proactive. Predictive analytics is one of the area where lots of innovations and are taking place. And I already talked about one of the area where predictive analytics is being leveraged. That is, predicting the breakdown of industrial machineries, and that helps organizations save billions of dollars. At the end, you will find a component, which is obviously the either applications running on user devices or enterprise applications running at remote locations. Right, so we call them backend applications, and these backend applications have to be connected to cloud platforms. A cloud platform, in most of the cases, a cloud platform acts as a bridge. It it connects your devices deployed across the field, with backend applications either running on user devices or enterprise applications. So the picture over here on my slide, this will give you an idea of an end-to-end IoT ecosystem. So we just talked about the composition of IoT ecosystem, and as you can see here in this picture, at one side we have those things, and these things come with lots of inherent heterogeneities, and so one of the problem you are going to face here, one of the challenge you are going to face here, is how to connect them to internet. So there are two types of connectivity options available to us. Either we connect things or endpoints directly, by embedding some kind of communication technology in them, which enables them to use internet as a communication channel. So either you enable your devices to directly connect to internet and then communicate with the cloud platform, or you enable your devices to talk to a local system acting as a proxy for them. So this local system, which is there to enable your endpoints to talk to cloud, is called a gateway. Right. So one of the role that gateway plays, and gateway is on premises uh, node. Okay. So one of the role gateway plays in an IoT network is obviously an enabler. It helps non-IP capable devices to connect to internet. And gateway could it can play multiple roles. The second role a gateway can play is obviously it can enable your devices to work in offline mode, without any internet connectivity. Uh, by offering them the services which are usually offered by cloud platforms. It also a gateway also offer you, you know, a platform, a runtime environment where you can have advanced machine learning algorithms deployed, and that enables this gateway to react to the signals or data coming from the devices in almost real time or in near real time. Most of time this type of requirement would come from industrial control systems. And last but not least, a gateway can also play role of a security node, because when you go for gateway-based architecture, uh, it the gateway is the node, from is the only node, from where your data and commands will go in and out. So a gateway is the node where you can have your security solutions deployed. So once you deploy your security solution on gateway, it not only guards the gateway itself. It will actually guard your entire network against all the external threats and other risks involved in getting your devices connected to internet, right? So these are and there are, it's just limited to your imagination. You can think of hundreds of other types of computations deployed on a gateway node in your network. Okay. Now, once you have this gateway or your device is directly connected to a cloud platform, obviously a cloud comes with uh, unimaginable potential, and it offers hundreds and thousands of services to help you build uh, either your uh, rest of the solution, rest of your IoT solution on the cloud itself, or a cloud may offer you endpoints to have this entire uh, uh, deployment of your devices in the field along with gateway to be integrated with backend applications running on premises or at remote locations. So cloud offers two types of endpoints: device side endpoints, which enable devices to be connected to it, and service side endpoints, which enables the cloud-based solution to be integrated with backend applications. This application may run on user devices or on-premises infrastructure, as I pointed out. So this is the end-to-end composition of an IoT ecosystem, and you might have got an idea now. It's not an easy task. It's really a complex endeavor when it comes to designing and developing IoT ecosystems, right? Because uh, it demands a sound understanding of all the subdomains and sub-technologies, right? So there are areas like and one of the area and the professionals who may help you learning IoT, from with a better perspective is obviously embedded system professionals. Because if you look at this technology, and as Kevin Aston pointed out, this technology has emerged, from the applications of computers, and embedded system is one of the areas where professionals have been using these computers to enable products, and we have billions of those products around us. So embedded system is naturally a subdomain of IoT, and other areas like sensor technology, the internet communication part, network technology, cloud, big data, machine learning and AI, and enterprise solutions. These are all subdomains of IoT, right? So when it comes to designing and developing IoT ecosystems or IoT solutions, either uh, you will you will be required to have an understanding of end-to-end and all the subdomains, or else an organization, let's say when it comes to developing enterprise solutions, obviously an organization will have to build a team of professionals, and this team uh, would have professionals from all the subdomains of IoT. So this team must have professionals from embedded domain, from networking domain, from IT domain, from cloud computing domain, from DevOps domain, from big data domain, and also machine learning and AI specialists. Right. So uh, either a person develops a combination of skills, learn a combination of skills, or a team having a combination of skills would be the right option to initiate or embark on an IoT project. Okay. Uh, so here, as I just pointed out, an IoT ecosystem is a combination of all these components. Okay, so if you guys have any questions or doubts from this slide or from the previous slide which were discussed earlier, please raise your hand, and I would request uh, those who do not have any questions, or if you think there is a background noise in on your side, please avoid raising hands. Okay, so I'll take question from uh, Vishwakarma. Vishwakarma, you raised your hand. Do you have one question?
I haven't raised it.
Okay. Okay. Ankit Gar. Ankit Gar, got any question? Okay. I don't see people. Those people who are raising their hands. No, they are not ready to ask questions. So let me do one thing. Let me have a look at the panel, question panel. Okay, so Mohammed Mohammed Hossein, he says, please explain gateway's role in IoT again. So Mohammed, I just pointed this out. One of the role a gateway plays is protocol converter or enabler. For example, if your device is a Bluetooth device, if it is using Bluetooth to communicate with other devices, obviously Bluetooth is not an IP capable technology, right? So in that case you would need an intermediate node which could help your Bluetooth device to connect to internet. Okay, so one of the role gateway plays is it's an enabler or protocol converter. The second role a gateway could play is obviously it can act as a store and forward network, and that would help you running your deployment in the areas where internet connectivity is either intermittent or poor, or even if you lose your internet connectivity, right? A gateway can also help you secure your entire deployment, right? So there are multiple roles a gateway can play, right? So I hope this answers the question. Okay, Ujjwal Patel says IPv4, IPv6, which is best for IoT development. So Ujjwal, IPv6, obviously, why? Because it addresses one of the problem being faced by, IoT community, and that is how to uniquely identify, these billions of devices which are going to be connected to internet, right? So obviously IPv6 is the answer to device identity issues or problems, right? But IPv6 will take some time because we cannot, you know, uh, uh, replace IPv4 overnight, right? So currently, most of devices support both IPv4 as well as IPv6. Okay, so IPv6 is essential for IoT to happen. I hope this answers the question. IPv6 is the future. Okay. There is another question from Sai Sarath, and he says, where does gateway exist, either in user's device or in the server? So Sai Sarath, gateway is a server. It acts as a server. It is placed on premises. So and that depends, because let's talk about a car. So a car may have 40 or 50 microcontrollers, and these microcontrollers performing dedicated tasks, right? So in a car, you can have a gateway device. okay, embedded in the car itself. Okay, so a, a powerful microcontroller or a powerful SoC can act as a gateway device for rest of the microcontrollers embedded in the car to perform dedicated tasks. Okay, you can have a gateway device. For example, let's talk about smart home systems. So in smart home systems, you can have a gateway device, uh, connected to your network as a separate system. Okay, so there are this smart gateway solutions from organizations like Norton, and this gateway solutions, they come with built-in security. So I would suggest you to visit Norton's website and search for smart firewall systems for smart homes. So from there you can find more information about the role of gateway, as well as where uh, do we place this gateway. So you can have this embedded in the systems or connected to your network is independent or separate nodes. Okay, so guys, I have hundreds of questions here in the panel. So I'm in a position just to answer 3 or 4 questions, and then I'll resume my session, because otherwise it will consume lots of time. Okay. Zainab has a question. She says, "What is difference between WOT and IoT?" So difference is in, Zainab, it's difference is in the architecture. So there are two types of architecture we use when it comes to enabling systems to use internet as a communication infrastructure or as channel. One is push based and second one is pull based. Right. So push based means where we enable devices to connect to cloud and then pull the information from there. Now these are devices which act as consumers. So we have endpoints acting as consumers, and they are interested in data lying on cloud platforms. Okay. And the second type of devices are those devices which are source of information. So a device may have data with it, okay, acquired acquired from the environment with the help of sensors, and this device, now once it acquires data from the environment, it becomes a source of information, right? So this type of devices, WOT, the concept of WOT is to enable devices to act as source of information. Enable, just like websites. When you visit a website, actually you are visiting a server, and then this, on that server you will find lots of information, right, which may be meaningful for you. Similarly, WOT is promoting the concept of enabling these devices to act like servers. These devices will have their own data and other resources, and this data and other resources can be discovered, queried, and retrieved, with the help of conventional technologies like HTTP and WebSockets. Okay, I hope this answers the question. So this is just one of the concept, and so many, as I pointed out earlier. I answered one of the questions, in line with this question earlier. Most of these concepts are being promoted by different groups, but they all mean same thing. Not, there is a slight difference between the approaches, but at the end you would find it's all about building that smart city, or sorry, a smart environment of intelligent products, offering services, better services to end users. Okay, so the last question I would answer is from Venkatesh, and says, I have a lot of background noise. Okay, no problems. Why all are so confident IoT will be in top position by 2020, like in terms of uses or jobs or future? So Venkatesh, this is the evolution of IoT is almost inevitable. We in India, we have started exploring IoT. So I'm just sharing my personal experience. I've been working as a trainer for past 10 years, and I'm sharing my personal experience. Most of the organizations have been in the, have been exploring IoT, for business opportunities for the last 2 to 3 years, right? And now IoT is entering into implementation phase, and organizations have really understood the potential as well as they have realized all those that IoT promises. Okay, so this is the time when organizations have fixed their budget for IoT adoption. So it's almost inevitable. IoT is going to happen, and 2020, yes, 2020 will cross that figure of 50 billion devices. In fact, now it is being anticipated that this figure may raise to more than 100 billion. Okay, so believe me, this is one of technology which promises to offer jobs to almost 40% of the population on this earth. You know, so it comes with a great promise when it comes to employment opportunities. Right? I hope this answers the question. Okay. And there is an interesting question. So this comes from Deepak Rao. He says DevOps plus MC plus Python. Yes, Deepak. So I already answered this question, right? DevOps is one of the subdomain of IoT. So IoT is an ensemble of. Let me simplify it for you. IoT is an ensemble of all the technologies we have invented so far. Okay. So DevOps is one of them. And Python, yes, Python is a great language. It comes with it's a highly versatile and it has application in almost all the areas. Okay, so yes, I'll I'll resume my session because we have a lot to discuss. Okay, so I'm coming to IoT endpoint architecture now. Okay, so endpoint means we use those terms for endpoints. Sometimes we call them things, sometimes we call them objects, embedded systems. All those terms we keep using interchangeably. An IoT endpoint, if you look at my screen, an IoT endpoint is a combination of four essential components. Okay, sensing, and sensors. There could there can be more than one sensor embedded in an endpoint. A computer, and this is not for high-end processing. Okay, a computer to acquire data from the sensors. Okay, and then pre-process it, just pre-processing, not high-end processing. Okay, it means we do not need a high-end computer to be embedded into a device. Okay, a group of actuators. Actuators are components which allow computers to generate physical action to influence a physical environment or manipulate a physical environment. Okay, and then we have the fourth type of components called communication interfaces. A communication interface can be a wired interface or a wireless interface, and we have an array of options over here. Okay, so these are the four essential components you would find embedded in a larger system to transform or turn it into an IoT endpoint. So let's say if you have a shoe or a wristwatch or a TV or a conventional, electromechanical system, for example, a lathe machine, on a factory floor. Once you embed these four capabilities in that electrical, mechanical, or any other type of system, uh, you know, it, it potentially turns it into an IoT endpoint. Okay. Now, when it comes to designing and developing these endpoints, obviously, the first component that you will have to select is a sensor. Right now, what does a sensor do? A sensor converts physical signal into electrical signal. Right, and why electrical signal? Because electrical is the valid input you can feed into a computer system. You know, so next thing, how many types or of sensors you would come across, right? So we use sensors which are called active sensors, which do not require power to work, and we have passive sensors. Passive sensors, they require external power source, to work. Okay, we have analog and digital type of sensors. Analog sensors, cannot be connected to computers directly. Digital sensors, yes, this is the input that computers would accept, happily, right? So a digital uh, sensor can directly be connected to a computer system. Okay, then we have conventional sensors and smart sensors. The smart sensors are, new generation sensors. So most of the time, this smart sensors already have, microcontrollers embedded in them, and the data coming from them will come well formatted. Okay, conventional, sensors are pure electromechanical systems. For example, a piezoelectric sensor, or a microphone. This type of sensors are called conventional sensors. Now, when it comes to selection of a sensor, and believe me, this is really a critical area, which would require, uh, you know, uh, lots of attention. Why? Because the data that we collect from the environment with the help of sensors, this data would be leveraged, to make decisions. Now, believe me, there is a principle, right? Garbage in, garbage out. So when you capture inaccurate data from the real life environment with the help of sensors, it's not going to help you adding any business value in your overall IoT ecosystem. Okay, so your IoT ecosystem will totally be dependent on the quality of data. You know, quality of data that really matters, right? So this is the reason why when it comes to selection of sensor, you will have to be extremely careful. Select a sensor looking at its characteristics. Now uh, the accuracy, precision, sensitivity, range of input and output, and grade, whether the sensor being selected by you is industry grade or not. Industry grade sensors or military grade sensors have to be selected for applications. If your applications come from industrial or military areas, you will have to select, industrial grade sensors and military grade sensors, right? So be careful. Okay, the quality of data really matters, and this is the reason why, uh, you should always look at the specification and data sheet of sensors, and you should always look at these parameters. The data have to be accurate and, noise free. Okay, now it comes to the next component that would be required to build an IoT endpoint is obviously, a microcontroller. And already shared three types of computers with you, right? There are conventional computers, there are industrial computers, and there are single chip computers. So MCU here, the term MCU refers to a microcontroller unit. Okay, and MCUs have evolved over the years, into SoCs. SoC, the term SoC refers to system on chip. So a chip may have a computer, a single chip computer, along with, other interfaces and computing logics. So a SoC will have MCU. Along with MCU, you'll find other logic circuits, are fabricated on inside same chip. Okay, so SoC is a full-fledged system. Okay, so for example, to build a mobile phone, you'll just need one chip. To build a TV, you will just need one chip. That chip will have all the features and logic circuits fabricated inside it. Okay, so SoC is nothing but an extension of MCU. And what is MCU? MCU is a single chip computer where you will have, processor, storage memory, processing memory, and all the I/O logics, fabricated on a single silicon wafer packed in a plastic package. Okay, Now, this type of MCUs and SoCs are being manufactured, especially IoT-ready MCU and SoCs are being manufactured by chip manufacturers like Intel, Microchip, Texas Instruments, and ARM Limited. These are the leading supplier of MCUs and SoCs. And when it comes to selection of MCUs and SoCs, you will have to be again extremely careful, because the MCU and SoC, products, whether your products would be successful or not, it would depend solely on the selection of MCU and SoC. Okay, so the parameters that have to be taken into consideration are performance, obviously, speed, and there are two ways of measuring speed of a computer system. Either it is mentioned in the form of clock speed, gigahertz, right, or it's going to be mentioned in the form of throughput, millions instructions per second, MIPS. Okay, the second parameter that you will have to be taken into consideration is obviously storage memory. What kind of memory is there? Okay, especially when it is EEPROM. Okay, and storage memory is used to store programs and data permanently. Processing memory will make your system faster if it is large, like larger in amount. Okay, IO interfaces, and this is again a critical parameter, because you you are going to build, you're going to build connected product, right? So connected products, and most of the MCUs and SoCs nowadays come with on-chip, communication interfaces, and wireless is the predominantly used connectivity technology, right? So most of the SoCs and MCUs will have Bluetooth and Wi-Fi communication capabilities available on chip, right? So when you go for SoCs, this is the benefit, right? SoC will have uh, on-chip I/O interfaces, right? So that would help you build a compact product with uh, it's a physical form factor, would be lesser compared to when you go for microcontrollers and or microprocessor based solutions. Now, the next parameter that would require your attention is obviously power consumption, especially if you are building battery operated devices. Okay, see, the SoCs or MCUs, they are the computers, they are the brains, which are going to be embedded in your products, So obviously, the most active component will consume most of the power, So computer or MCU or SoCs, whatever you embed into your system, it is the component which is going to consume most of the power, and it will take down your battery, easily if your battery is not powerful enough to keep it running for let's say days or months or years, right? So power consumption should always go for uh, MCU or SoC, which offers you high performance, but at the cost of low power, right? So this is, if you visit this website of suppliers like TI, Texas Instruments, or ARM Limited or Microchip, you will find, their SoCs and MCUs product portfolio offering high performance, low power, computers. Okay. Security is obviously something that has to be one of the component that have to be taken into consideration, at the time of design itself. So there is an approach called secure by design. Think of incorporating security in your product at its initial phase. So it's not just you build the product and then think about security. No, here the system would be a closed system. Your IoT product is going to be a closed system, so it will be difficult for you to bolt security on top of it once you have completed your product. Okay, so security should be design, should be a point which have to be taken into consideration during the design phase itself. Okay, so that once you go for development, security is already incorporated in your product and solution. Okay. Cost, obviously, because the product has to be cost effective, right? So while selecting a microcontroller SoC, cost has to be taken into consideration, right? So now when it comes to design and development of IoT uh, products, there is always a phase called POC, proof of concept, right? So you will have to build a solution to present it to your end user or to your management to help them understand its the business use case, right? So when it comes to POCs, there are several off-the-shelf hardware prototyping boards available. So we have open source uh, hardware prototyping boards like Arduino, Node MCU, Raspberry Pi, and there are high-end prototyping boards from Intel like Galileo and Edison. Uh, we have this BeagleBone from ARM, right? So there are so many, there are several this off-the-shelf prototyping boards available, and this boards can easily be programmed by using languages which have been derived from the conventional languages like C and C++ and Java, right? So POC, building a POC project, it doesn't require that much effort, but keep one thing in mind. While building POC, proof of concept projects, you may ignore most of the parameters which are being discussed in this presentation, right? But keep in mind, when it comes to actual product building, you know, you will have to take everything, whatever is being discussed here, into consideration, right? All these parameters which are listed over here on the slide. Okay. Now, the next thing that obviously I'm not going to talk about actuators over here because this is going to consume lots of time. Let me tell you something about communication technology. And believe me, this is one of the most interesting topic, right? Because here we have a range of options available to us. We have wired communication technologies, we have wireless communication technologies. Again, when it comes to wired communication technologies, we have several protocols. Ranging from the simple two-wire bus UART to 4-wire bus SPI to again two-wire master and multi-slave bus called I2C, inter-integrated communication, invented by uh, Philips. SPI was invented by Motorola. We have Ethernet, which have been there for years and have been helping your computers, not only your computers to connect to each other, but also helping you building industrial, network of, machineries. On the industrial side, we call it industrial Ethernet. Okay. When it comes to wireless options to connect your devices to each other, we have NFC, near field communication. We have RFID, radio frequency identification system. We have Bluetooth, and believe me, Bluetooth and Wi-Fi. These are the most wonderful technologies, right? Uh, and we have LoRa, stand for long range. Sigfox, again, for long range communication. These two technologies, including and NB-IoT, we call them LPWAN technology, low power wide area network technologies, right? So most of these technologies, they offer you, what do they offer you? They offer you connectivity, physical connectivity between your devices. Okay, you can have your devices physically connected to each other, and connectivity is essential for communication, right? Communication cannot happen unless you have some kind of physical connectivity between your devices. Okay, so this technology which are listed over here are going to help you physically connect your devices. For example, NFC offers you a range of hardly few centimeters. Okay, Bluetooth and Wi-Fi, they offer you ranges in meters. Okay, LoRa and Sigfox, they offer you ranges in kilometers. And cellular, obviously, it's almost ubiquitous. It's everywhere. It will offer you connectivity across the globe. you know. So now when it comes to, obviously, when it comes to selection of a communication technology to enable your product, it's again a complex endeavor. Okay, we have to take all these parameters into consideration. Data rate, the technology has to be not necessarily high speed technology. Okay, see, there you will come across IoT use cases where uh, uh, you would prefer, or where you would see uh, trade-offs trade-offs existing. So sometimes you will sacrifice data rate to gain power consumption or a longer coverage. Okay, so you'll have to think about data rate, and that too based on your use case. You will have to think about and take the range or coverage, being offered by your technology. Power consumption is obviously because your hardware, those transceivers which are going to be embedded in your devices, they consume lots of power. Okay, so be careful when you go for. So and I'll talk about that later on. Uh, you should also think about interoperability at this point itself, because interoperability means your system, because your system is going to be part of a larger ecosystem. Okay, so your system, you should keep in mind that your system must be able to interoperate with other systems. Okay, it must be able to design in such a way that it believes in coexistence. Coexistence, it's a society, right? So your system has to be disciplined system. Your system has to be a system which which exists in a larger ecosystem without disrupting that system. Okay. Obviously, when it comes to technologies, for example, Bluetooth, it's not an IP capable technology. Wi-Fi is an IP capable technology, right? So this is something that you will have to take into account, whether you are going for direct connectivity from your device to cloud over the internet, or you are going for a gateway-based deployment, wherein like you will connect your device to a gateway, and then gateway will connect your device to cloud platform. Okay, so you will have to take capability of your communication technology into consideration. And last but not least, the most important part, security. Because this is, once you enable your device to communicate, once you connect your device to external world, it means you yourself are exposing your device. Okay, there is a risk involved here, and the risk is, there is going to be a possibility that your device can be exploited. So believe me, internet, when you connect your devices to internet, no one can guarantee the security of your devices. Okay, so network is one of the point, or from where the threats can enter into your system. Okay, so network or ports, these are the most vulnerable points. So when you think of, or when you select a communication technology, keep in mind, should always look at security features being offered by this technology. Okay, now, one of the most interesting thing that I would like to share with you is most of these technologies have been there for years. Okay, for example, Bluetooth, it was invented long ago, right? 1994. Wi-Fi, again, in almost 2 decades ago, right? These technologies at the time of invention were not invented keeping IoT in mind. Okay, but now with the advent of IoT and looking at the connectivity is not just an option. Connectivity is essential now, right? So looking at the essential requirement of embedding connectivity into more and more low power products, these technologies are being optimized now. So Bluetooth, we have a power optimized version of Bluetooth called Bluetooth 5. Okay, similarly, we have a power optimized version of Wi-Fi called Wi-Fi Hello, right? So most of these areas are being optimized. You must explore more about these technologies, and that would help you, understanding how these technologies are going to be used for physical connectivity. Okay. Now I'll quickly move to the next point, and this is one of the happening area. Edge computing. Okay. So see, advent of IoT. Okay. Has introduced so many new computing paradigms. So we have new computing paradigms or computing frameworks. Okay. Edge computing is a new framework. Okay. Edge computing means computing at the edge of your network. I already talked about gateway. So it's not just a gateway. A gateway is a computer. It comes with those kind of features which would offer you all the services that I talked about. But edge is not just a gateway. Edge, as I alluded earlier, edge will also help you address IT plus OT integration, and this is one of the area where manufacturing industries are facing lots of challenges. Because most of the time data coming from OT, operational technology domain, is unstructured in nature, and that unstructured data, requires special tools. So you will have to use special tools and applications to not only acquire it but to store it and process it. You will require specialized tools, and most of times this data demands real-time analytics. Okay. The data have to be analyzed at the source itself, or if not at the source, at least close to source, at a location which is closer to source compared to cloud. Because when it comes to communication between devices and cloud, there is always network latencies involved in that. And that network latencies will not enable your systems to control real-time processes. Okay. So in most of the scenarios, we would like computing taking place at the edge itself, and this is why this edge computing solutions are being offered as off-the-shelf solutions, by manufacturers like Cisco, Huawei, Dell, Intel, and many others. Okay. Similarly, so this companies, I named few companies just now. These companies, they offer hardware edge computing solutions or fog computing solutions. This is why Cisco calls it fog computing. Okay. So there's not much difference between fog and edge. Okay. Cisco calls it fog, just like IoE. Cisco calls Internet of Everything. The rest of the world call it IoT. Cisco calls computing taking place at the edge on gateway. Cisco calls it fog. Rest of the world calls it edge computing. Okay. Now, when it comes to edge computing, there are two high-end solutions, and these two solutions are software solutions being offered by cloud platforms like Amazon Greengrass from AWS and Azure IoT Edge SDK from Microsoft Azure. So edge computing is being offered as a cloud service now. You can call it an extended service. Okay. So this is one of the area where where you would see growth in coming time. And just one of the survey revealed that there is a requirement of 18 billion, 18, okay, 18 billion gateway or edge computing devices, and that has translated into a multi-million market, right? So this is why all these big companies are exploring this area, because there are lots of business opportunities over here. Okay. So edge, yes, it matters. And then the next component that I already talked about is obviously a cloud. So a cloud has commoditized computing, and a cloud is basically, there are different types of deployment models. For example, we have, so I'll directly jump to this slide. We have public cloud platforms, we have private cloud platform, we have community cloud platforms, and we have hybrid cloud platforms. So you can read more about this because we are running short of time. So I'll just make it quick for you. You know, uh, out of these four, public cloud platforms, there are two cloud platforms which are leading: AWS from Amazon and Azure from Microsoft. Okay. Now, one of the deployment model which is highly relevant to IoT is obviously hybrid. Hybrid where a combination of these two. For example, having a private infrastructure on premises and then this private infrastructure connected to a public cloud platform. This is a highly prevalent deployment model, hybrid. So as we are running short of time, I'll not talk about more about this, but anyway, I'm just giving you an insight. Hybrid is the prevalent deployment model or architecture. Okay. Now let me give you a real life use case. Okay, for example, whatever we discussed just now, different components of an IoT ecosystem, and I shared, just to give an idea, because 1.5 hour is obviously not enough to talk about this technology. Uh, it takes hours, and we can keep go. I can go on, when it comes to IoT. But anyway, as we are running short of time, let me directly jump to this use case. Okay, so I talked about two types of connectivity: direct connectivity and gateway-based connectivity. Okay, so when it comes to smart healthcare monitoring systems and wearable devices, the device that can capture data from a human body. This is one of the area where most of the companies are exploring IoT. Okay, and here we talk about wearable, a battery operated device with a sensor, microcontroller unit, and communication capability embedded in it. So the preferred communication uh, technology here is obviously Bluetooth LE. Why Bluetooth LE? Because it's a power efficient communication technology. Uh, Bluetooth LE, Bluetooth Low Energy, version 4.0 and now 5. These are IoT friendly Bluetooth versions. Okay, so BTLE along with a microcontroller, or you can use an external module, BTLE module, or you can have BTLE, Bluetooth Low Energy Communication, uh, logic circuit available on chip. You know Now, when it comes to this type of use cases, and as I alluded earlier, sensor, because you are going to capture data from a human body, where the signal strength uh, will not be or signal will not be that strong. So you will have to use hypersensitive sensors, and again you will have to focus more on the quality of the sensor. It has to be a medical grade sensor. And second thing, you must prefer to go for a sensor which provide you the kind of accuracy and precision, because obviously it's a critical area, right? So while selecting sensors, as I pointed out, you will have to take and you must take all those parameters into account which were discussed earlier. Now, when it comes to connectivity, obviously, a wearable, the best option to use a computer is gateway. For a wearable is a mobile phone, right? Because a person would carry both of them along with him. Okay, so with the help of BTLE, a wearable can easily be connected to a mobile phone, and on your mobile phone you can have an application which can offer a set of edge analytics capabilities to provide some kind of insights to the person who is wearing it. And at the same time, this application running on the mobile phone must be able to use internet as a communication infrastructure to upload this data on the cloud platform, or where at the other end, either you can have your entire solution running on the cloud platform and a doctor or a healthcare facility connected to cloud at the other end, or you can have, let's say, a hybrid kind of deployment model where you can have a part of the solution running on the cloud platform, which is responsible, not only responsible for the collection, storage, and processing of the data, but also responsible to forward, uh, or make all the insights derived from it available to, on device or on infrastructure, on premises infrastructure applications. Okay, so as you can see here, an IoT is a perfect example of a distributed computing, uh, you know, uh, uh, model. Okay, so an IoT, the real strength of IoT, and let me just summarize it for you. See, as we discussed, and first to build an IoT system, obviously you'll have to build an IoT infrastructure. Now, what we discussed today in today's webinar is how to build an infrastructure. I just talked about the components, hardware components to build a device. I talked about the architecture to connect your device to cloud. But the real strength of an IoT solution, doesn't lie in the infrastructure. The real strength of IoT solution lies in the applications running on this network nodes or points. Okay, so an application running on wearable, application running on gateway, application running on cloud, and application running on the user devices or on-premises infrastructure, they will they will have to work in a collaborative manner to offer a transparent experience to end users. Okay, and we would like this applications to work intelligently without any human intervention. This is what is desired. Okay, the next thing, and again, I'm sharing, one of the insights based on my experience. Most of the IoT project do not succeed. You know, and the primary reason is, this the lack of data-driven analytical strategy. Right? See, analytics. What to capture? I mean, say, what kind of data to capture? How much to capture? Where to store it? How to process it, what kind of analytics would run on this data. You know, these are all critical decisions. And last but not least, where how are you going to consume these insights? Whether you are going to present these insights to end users to make decisions, or you would enable your devices to take decisions automatically. So all these are the critical questions which have to be answered, prior to embarking on IoT's journey. Okay, so I just tried my best to cover as much as possible in this 1.5 hour duration. Okay, now in case if you have any question, and you know uh, I'm not in position to answer all the questions. I'll just answer 4 to 5 questions. Rest of the participants can share their questions with us, through the email address provided to them. Okay. So let me look at the question panel and answer a few questions from there. Just hold on, please. Okay, so we have a question, and the question is from Vishal Singh. He says, "What about Wi-Fi? Is it gateway device? What about Wi-Fi? Is it no? So Wi-Fi is a communication technology, Vishal. Wi-Fi is not gateway. Wi-Fi is a communication technology. Okay, it's a wireless communication technology. A gateway is a hardware device. Okay, I hope this answers your question. Okay, we have a question from Chittaranjan. His question is, how can this helpful for an IT professional without having any electronic device knowledge? So Chittaranjan, as I pointed out, you need not have an sound knowledge of all the verticals or all the components of an IoT ecosystem. Obviously, when it comes to large projects, enterprise level projects, companies hire professionals, with with the different types of skill sets. Okay, so if you're coming from IT domain, I would suggest you to learn basic IoT and then focus more on, an area where you find your skills to be perfectly matching with. Okay, for example, when if you're coming from IT side, I would suggest you to uh, focus on networking side of IoT, protocol side of IoT, or the cloud side of IoT, or the enterprise integration side of IoT. These are the areas where IT professionals are learning new skills and they are being hired by organizations. Okay, I hope this answers your question. Okay, Muralidharan has a question. He says, where to use analytics and how to use. So Muralidharan, this is analytics itself is science, right? We call it data science, right? So managing and then leveraging your data, this can be a topic of one of our future sessions. Okay, so I'll just uh, answer it in simplest manner. In an IoT network, you can have analytics running either on device or at the edge, as I pointed out, or on the cloud platform, or on your business infrastructure or devices. Right, so it means analytics is a distributed component in an IoT network. You can have analytics running at various points, and that may vary from project to project. Okay, that all depends on your use case. Okay, I hope this answers the question. Okay, we have a question from Vishwakarma, and Vishwakarma, you're talking about CAN, right? The technologies, controller area network technologies, technologies which come from yes. So those technologies can be leveraged. So we are not just uh, adopting that approach, rip and replace. We are the uh, existing domain specific protocols and technologies are going to be there. Okay. At the same time, this existing domain-specific technologies can be optimized. Uh, right. So this is what is being done by standard development organization right now. Okay. So I hope I have answered 4 to 5 questions. I have a list of more than 100 questions in front of me. So I'm really sorry. I will not be able to answer all these questions. But anyway, in if what I'll do, uh, I'll share answers of all these questions through email to each one of you. Okay, and that would come to you from our support team. Okay, for telecom, for example, yes, IoT has a requirement for you. You know why? And this question comes from Ritika. So Ritika, I've just pointed this out. Connectivity is essential for communication. You can only build and connect devices to each other if there is a technology helping your devices to physically gain connectivity with each other, right? And this is where telcos are offering, innovative communication models. For example, M2M, machine-to-machine communication technologies, NB-IoT, 5G. These are the technologies which are going to help IoT uh, IoT builders, you can say, right? Bharti's question is there a certification? Yes. So Cognitia offers certifications in IoT, Bharti, and these certifications are globally accepted certifications. Okay, you can contact our support team and sales team. They'll help you understand how to enroll for these training programs and and uh, you know uh, get yourself certified. Okay. I hope I've answered most of the questions here, and if your question has not been answered, please do not get disheartened. I'll get back to you, and we'll connect once again through email. Okay. Okay, just one more interesting question. There is Suvendu, and he says, how can it help me as I'm working on PLC and SCADA? Okay, so Suvendu, IIoT, as I pointed out, IIoT or industrial IoT, application of Internet of Things in the manufacturing sector. Read more about IIoT, and you will come to know, how your knowledge of PLCs and SCADA can help you building a successful career in this domain. Okay. One more question, and that is really interesting, and this is the reason why I'm answering this. From Vishwakarma, Rishika. And she says, do we have any dependency on cloud protocol? Yes, we do have dependency on cloud protocols, Vishwakarma. For example, AWS, it supports only HTTP and MQTT. Azure, it supports HTTP, MQTT, and AMQP. Okay, so you can connect your device to this cloud platform only when your device natively support this application layer protocols. Okay, now question is, what if your device doesn't support, uh, if device doesn't support one of these protocols supported by cloud platform? Okay, so in that case, the cloud platforms themselves are offering solutions. We call them protocol converters. You can have this protocol converter either running on the cloud at the front end, or you can have this protocol converters running at the gateway to enable your devices to connect and communicate with these cloud platforms. Okay. Okay. CJ Bhaskar. Uh, CJ Bhaskar, let me scroll up and look at one of the question asked by you. Okay, so your question is, which cloud computing service provide gives for free the max size for longer validity? Okay, so CJ Bhaskar, the best cloud platform when it comes to offering a free subscription is AWS. Okay, so AWS offers a free subscription for bunch of services for 12 months. Okay, and IoT, most of the services are pertaining to IoT stack. Okay, the second cloud platform which offers, and there are two cloud platforms which offer 1 month free subscription, Azure and Google. Okay, so these are the two cloud platforms which are offering free subscription for 1 month. I hope this answers your question. Okay, so guys, thank you very much for for attending this session, and I really appreciate your patience and the questions that you answered, question that you asked, which are here in with me in the question panel. There, all of these are great questions, and that shows how your enthusiasm to learn this technology. So thank you very much. We'll stay in touch. Uh, uh, you can drop your, in fact, whether you are willing to join our training programs or not, but anyway, I would suggest you to keep in touch with us, join our community websites on Facebook and LinkedIn, and stay connected with us for more interesting webinars in the future. Thank you very much. Good night.